My name is Alexis Dixon.
And I'm Matthew Kaminsky.
And I'm Brenda Lobera.
And I'm Mitchell Bryant.
And today we'll be talking about rotational systems, specifically generators and motors. And this is a presentation for Kate Davis's 340 class at Texas A&M University, fall 2019. So the first thing we're going to be talking about is generators. And so generators work by converting mechanical energy into electrical energy. And so this happens by either rotating a magnet inside of a conductive coil or rotating a conductive coil inside a magnet. So if we're going to rotate a magnet inside the conductive coil, that produces an electric field, which then induces a current, which is used to power whatever you need to power. And then the other way is if we rotate a conductive coil inside of a magnet, the coil will go inside and outside of the magnetic field, which also then induces a current, which then is used to power whatever you need to.
Next, we will be talking about examples of generators. Just like Alexis mentioned in the previous slide, we can use generators to transform different types of energy into electrical energy. And we have two examples here, roadway vehicles and wind turbines. And for roadway vehicles, an example of how this works is whenever you have your foot on the accelerator, you're working with the motor. However, when you take your foot off of the accelerator, you're working with the generator because it charges the battery. And another example is the wind turbines, and it's specifically how the wind turns the blades, and which is connected to the generator, which produces electricity. And here we have a picture of how it is all connected and how the generator is controlled by all of this around it. And the only thing with renewable energy is that it is very inefficient. However, these are only two examples of many that we see of generators.
Okay, so the main parts of a DC motor consist of the armature, the commutator, the axle, the brushes, the field magnets, and the power supplies. The armature is the part of the motor that holds all the copper windings that will interact with the magnetic field. The commutator is a type of switch that will reverse the current flowing through the windings to prevent the torque from reversing each time the coil moves through the plane perpendicular to the field. The brushes are connected to the axle, and these power the coils, and they consist of a low friction, high conductivity material. These tend to actually wear out over time, and they will have to be replaced. The field magnets are typically, but not always, permanent magnets. A motor that uses permanent magnets will typically have less power, or it will typically require less power than a motor that uses electromagnets as the field magnets. And the power supply, in the case of this motor here, it's going to be a DC power supply, but some motors will actually use multi-phase AC power to power the coils.
And on our next slide, we're going to talk about examples of motors and uses. The first image I have here is an electric motor. It's a universal electric motor. It operates on AC or DC. It's powered by these two, and they are typically really lightweight and compact motors, and they produce a very high torque, so it's really good for your household appliances and kitchen appliances. And then on our second image, we have a brushless DC motor, and these are powered by a DC, which is used to produce AC current through a switch that powers the power supply and then an inverter. The current drives the phase of the motor, where a controller provides the pulse to the motor windings, and this induces the energy that you need, and this controls the speed and torque. And you use these two things to power things like a DVD player, a CD player, and there are also other appliances at your house that will use this type of motor.